At first, I thought I'd take the advice that Nelson gave to his captains before the Battle of Trafalgar concerning the enemy. Go at them. So my first idea was video 1 derivatives, video 2 integrals, but then I realized that to make things interesting, I needed some good examples, and that meant a first preliminary video. This one. Now, the goal of my course is not just to teach you mathematics or calculus, but to teach you to have mathematics almost as an intuitive sense, almost to understand it in an intuitive way so that you know the meanings behind everything. Not that you can just do it, but you understand why it works. So, let's begin with the preliminaries. Alright, start with coordinates in one dimension. So, begin with a number line, or a straight line. Mark 2 points on it, 0 and 1. Now, it's an equal increment from 0 and 1. Let's just fill in every number. 2, 3, -1, -2. Now, I've only drawn the integers here, but I imagine every number in there. You know, -pi, e, square root of 2, etc. And any number that is that you can ever think of and put on this number line, every little increment, we indicate that by drawing this symbol, which means all real numbers. So basically this symbol is the collection of every number that is. Okay. Now let's move on to the plane. So pick a point and call it O for origin. And you draw 2 lines through it. There's one line perpendicular to each other, one going horizontal and one going vertical. And you label them as Y for the y-axis and X for the x-axis. Now, the O, or the origin, corresponds to 0. Then you'll have increments. Usually when dealing with calculus we go pi halves, pi, but that's a story for another time. So, to find any point, P, in this plane, we see where it hits on the x-axis, and we call that point A. Then we see where it hits on the y-axis, and we call that point B. So the location of P is just A, B. And we denote the location of P by saying P of AB. I presume that you know all this, but I've gone over it because it's one of the greatest ideas in mathematics. It turns geometry into algebra and algebra back into geometry, and it's due to a man by the name of Rene Descartes. And this plane here is called the Cartesian plane.